Good day, viewers. Today we are going to be learning how to solve this simple exponential equation using Lambert function. Now, to prevent confusion later in the video, if you are new to Lambert function, in the comment section there is a link that will take you to my introduction video on this. Okay, so let's continue. Now, as usual, the aim of Lambert function is to express our equation in this format. Okay, so first of all, when we compare, we'll see that in this equation here, we have just one term of the variable and a constant, but here we have two terms of the variable. So to eliminate that, let's divide both sides by 5 raised to the power x. So we are going to have 5 raised to the power x divided by 5 raised to the power x equals 5x plus 15, all divided by 5 raised to the power x. So this cancels this, gives us 1, which is equals to 5x plus 15, then times 1 all over 5 raised to the power x. We can express this in an index form. So we have 1 equals 5x plus 15 times 5 raised to the power negative x. Yes, we are making a very, very big progress. So let's flip this so as to look exactly like this. We have 5x equals 1. We just flipped it. We haven't done anything much. So we see that we are getting close to this. Now, but we have a lot of difference. First of all, our x here has no coefficient of 5. There is a coefficient of 5 here. So let's get rid of that by factorizing 5 out from here. So we have 5 into brackets x plus 15 divided by 5 is what? 3. Then 5 raised to the power negative x equals 1. So we divide both sides by 5 to get rid of this 5. Divided by 5 divided by 5. So we have x plus 3, 5 raised to the power negative x, then 5 raised to the power negative 1 in index form. Nice, we are making a very, very big progress. But we have very, very big problem because our term of x here and the coefficient here are totally different. First is that there's 3 here, there is not 3 here. Here is positive, here is negative. What are we going to do? Looks like a lot of work, right? Very, very easy. First of all, let's introduce the 3 here. Let's introduce what? 3. Now, we're going to multiply both sides by 5 raised to the power negative 3, not 5 raised to the power 3, because if we have plus 3 here now, it's very, very hard for us to make the sign same as this. So the best is to multiply both sides by 5 raised to the power negative 3, right? So we have x plus 3, 5 raised to the power negative x times 5 raised to the power negative 3 plus 5 raised to the power negative 1 times 5 raised to the power negative 3. Now, from the law of indices, when we are multiplying, we have the power. So we have x plus 3, then 5 raised to the power negative x minus 3 plus 5 raised to the power negative 4. Now, we can now factor out negative 1. Can you see the wisdom there? So we have x plus 3, 5 raised to the power negative x plus 3 equals 5 raised to the power negative 4. So this work is just about wisdom. Can you see? We have factored out the negative here. So we have x plus 3, x plus 3. Now, we still have one more comma. We have minus here in the power. We don't have minus here at the coefficient. Very easy. Multiply both sides by negative 1. Negative x plus 3, 5 negative x plus 3 equals negative 5 raised to the power minus 4. Are you following me? Now, we are making a very, very big progress because when we compare them, our coefficient here is exactly the same as our power, same as m. Here, our m stands for negative into bracket x plus 3. I'm making a big progress. Now, we are left with last problem. What is that problem? The problem is only e. We need e here, not 5. We need Euler's constant, not 5. How do we do that? We use the law of logarithm. So I'm going to expressing this 5 as the power of logarithm. So it's going to be negative x plus 3 times, instead of writing 5 now, we'll express it as e raised to the power ln 5. Then negative x plus 3 equals to negative 5 raised to the power negative 4. Now I haven't done anything strange here. Is this 5 I've expressed like this? According to that law, ln cancels e, because this ln has a base of e. So let's press further. We are getting very close. Let's multiply the 2 power to take away this bracket. We have negative x plus 3 times e raised to power minus times plus is minus ln 5 times x plus 3 equals negative 5 raised to power negative 4. Now we're making a big progress. We now have E in our equation. Very good. But E came at a price. What is that price? Ln 5. No ln 5 here. Don't panic, it's very easy. To get ln 5 here, multiply both sides by ln 5. Because ln 5 is a constant. So we can do that. We have times negative x plus 3 times e raised to power negative equals to ln 5 times negative 5 raised to power negative 4. Okay, so let's rewrite this as this: negative ln 5 to bracket x plus 3, so equals to ln 5 times negative 5 raised to power negative 4. I'm making progress, and now finally we have gotten our equation in this format. We have the coefficient of our variable, same as the power of our variable, equals to a constant. Now we can now use Lambert's what? Omega function. Don't forget, m in this case represents negative ln 5 x plus 3. As simple as ABC. So we're going to take Lambert function of both sides. Okay, so we have Lambert function of negative ln 5 times negative 5. Yes, we're making a big progress. Don't forget, from the property of Lambert function, it cancels this format out. They were now left with this coefficient. So it will give us negative ln 5 x plus 3 equals to, as usual, this will give us a specific value, but to eliminate approximation, I will write it here. So you solve for x normally as you have done in a normal simple equation. So what we do here is we're going to divide both sides by negative ln 5. So we have divided by negative ln 5 divided by negative ln 5. So we'll be left with x plus 3 equals ln 5. Okay, so to solve for x, we'll transpose this to the other side and it becomes negative 3. So we have x equals minus 3. So when we impute negative Lambert function of ln 5 times negative 5 raised to power negative 4, all divided by ln 5 minus 3 into our calculator, as you can see on the screen, it's going to give us